Okay, this is on Chapter 3, Section 4, and I just kind of want to remind you of some things. These are all real important facts. It's a nice little summary. You can print the screen, write it down. I suggest if you write it down, you'll retain it more. But a unique line, so we'll just start out with the top. Some of these things we'll actually cover today, but I'm going to give it to you now. So a unique line is determined by two distinct points or a fixed slope in another point. So let's see that in GeoGebra. So here I'm going to have, I guess this will be the one I want. Here's my point, and there's a whole bunch of different lines. As soon as I fix another point, then I have a unique line. Doing it again, if I fix a point and I say the slope, notice every time I move this line I have a different slope. So if I say the slope is fixed, then it cannot move, and I don't have to put that line, that point there, D, but I put it there to lock it in place. I have a distinct line. So the point is, a unique line is determined by two distinct points or a fixed slope and another point. So the slope of a line is the ratio of its rise over its run. So that's the change in the y values, because the y goes up and down, over the change in its x values. Those go horizontally. The slope is a real number. It's not a variable term, and there is no variable x. It's the coefficient to the variable x, but it's just the coefficient. I don't know how many times I see on exams when there is a question, what is the slope of the line, and it's written in y is equal to mx plus b. The answer is mx. No, the answer is just the number m, no x in it at all. So vertical lines have undefined slope, and we'll see why that is, I think, today. Yeah, we'll actually see here in just a second. Their equation, the equation of a vertical line, can always be converted to an equivalent equation of the form x is equal to c for some real number c. And that, if you find that real number c on the x-axis and draw a vertical line through that number on the x-axis, then that's your vertical line. Horizontal lines have slope equal to 0. So y is equal to mx plus b. M is equal to 0, so that gives you y is equal to b. So the equation can always be converted to an equivalent equation of the form y is equal to b for some real number b. So you look on the y-axis, you find that number b, and then you draw a horizontal line through that number b, and you've got it. Here's some interesting things. Two distinct lines are parallel. That means they're not the same line, but they have the same slope. And because they're different lines, they will have different y-intercepts. And two distinct lines are perpendicular. I don't even know if you can see my hands there, but two distinct lines are perpendicular if the product of their slopes is -1. So these last two, so what I am thinking, all of this first part up here should be a review for most of you. You should have been in some way introduced to all of this somewhere before you actually are in this class. The two new concepts for this week will be parallel and perpendicularity. Anyway, let's go back to the actual notes. So the slope of a line, you should be able to actually answer that itself conceptually. You know it's the rise over the run. So, where's my pen? The slope of a line is slope is the rate of change in vertical to horizontal distances. This is a really informal definition. I think it's better just to remember slope is equal to rise over run. And this should also give you the picture I want you to associate with that. It's going to be a fraction, and the rise has to do with a vertical up and down direction. The run has to do with a horizontal direction. Now, this is probably going to look blurry to you. This is actually something that I copied from the textbook. So I'm going to just draw another picture for you rather than you thinking, oh, YouTube is blurry, and we'll calculate how to find the slope of a line if we find 2 points on the line. So let's just do that down here. So I'm going to go ahead and draw. So this is going to be my y-axis, and this is going to be my x-axis. And here, I'm just going to draw some arbitrary line. So remember, of course, this line goes on forever and ever. And now what we're going to do is I'm going to locate 2 points on the line. So right there is going to be 1 point, and I'm going to put the other point right here. Now, I don't know much about those points, but I know this is a point, so it has a specific x value and a specific y value. And I put subscripts on it because x1, x sub 1 or x1, and y sub 1 are 2 actual numbers. Down here, I know it has a coordinate as well, and I'm going to call it x2 and y2. So now let's think about the slope. So the slope is the ratio, is the ratio of the rise over the run. So I overshot just a little bit, and not that it matters. So how do I find, this is the rise distance, that's the up and down, and this is the run distance over here. Well, let's go ahead and drop a perpendicular down. So this right here is x2. I'm going to drop a perpendicular down, and this point right here on the x-axis is x1. So x1 minus x2 is equal to the run. Well, what about the rise? If I come over here, I'm just kind of doing this the best I can, and I drop a perpendicular down to the y-axis, this will be a value of y1 on the y-axis, and doing the same down here, I'm going to have a value of y2. So y1 minus y2 is equal to the rise. So that gives us the formula. If x1 and y1 and x2 and y2 are points on the graph, then the slope, m, is equal to rise over run, which is equal to y1 minus y2 over x1 minus x2. Now remember, whenever we're dividing something we have to make sure that we're not dividing by 0. So the only time the denominator will be 0 is when x1 and x2 are the same. So provided x2 is not equal to x1. When x2 is equal to x1, the slope is undefined, and we have a vertical line. So let's put this into practice. I'm going to show you some, we'll actually plot this. So we'll go ahead and do this. Take a screenshot of it. Copy her to the clipboard. And I'm going to start a new canvas here. And we'll move up. So here's the problem we're going to do. We're going to find the slope of the line that passes through the point 0, 3, and 2, 5. So just for the heck of it, let's see what that slope looks like. And then we'll actually use the formula. So we're going to find the point x is 0 and y is 3. So that's 1, 2, 3. So this is the point 0, 3. Now we're going to find the point 2, 5. So there's 2, and I don't love this. And there's going to be about 5, halfway in between through there. So our slope is going to be the slope belonging more or less to this line right here. I just put little arrows at the end that indicates that it goes on forever and ever. And this is the point 2 and 5. So I have 2 and 5 is equal to 1 point. And if you want, you can call it x1, y1. It doesn't matter. And 0, 3 is going to be equal to x2, y2. So the slope is equal to y1 minus y2 over x1 minus x2. So let's do that. So y1 minus y2. So I look at the y's first. 5 minus 2. And then 2 minus 0. 2 minus 0. So that's equal to 3 halves. And that's our slope. So notice what I did there. You can arbitrarily choose, I kind of stack them together, stack them on top of each other, and then I start with the y coordinates because I want the numerator first, and then I go and I subtract the bottom number from the one above it. But the thing I want to show you is that it doesn't matter which of those 2 points you choose to be on top. We'll get the exact same answer if we choose 0, 3 to be on top and 2, 5 to be on the bottom. So again, 3 minus 5 is minus 2, 0 5 minus 3. Sorry, people. Notice how I caught that. It's not 5 minus 3, it's 5 minus 2. Hold on. Let me correct that. 5 minus 3 over 2 minus 0. And that gives us 2 over 2, which is a slope of 1. Sorry about that. Wrote down the wrong thing. But my point was, and what I'm going to go back to, is it doesn't matter what I write first. I can put 0, 3 or 2, 5. So 3 minus 5 is minus 2, and 0 minus 2 is minus 2, and I still get 1 is the slope. So that's going to be the technique that we're going to use. It makes you don't have to memorize a formula. You just remember, all you have to remember is that the y values go in the numerator and the x values go in the denominator. By that, I mean the difference of the y values, numerator, the difference of the x values, denominator. So let's do another one. Let's go ahead and get a new. The reason I'm getting a new canvas is it imports that, I think, as a bitmap, and it starts taking resources, and it becomes sluggish, and who wants to deal with sluggish anything? So let's go ahead and do it over here. We'll do both. We'll actually plot and find. So we got everything we need. Get us some space. Come up. So let's actually do this one. We'll plot them first. So I'm looking for 5. So 5 is about, I don't particularly love this because notice 5 is right in between 4 and 6. So that's 5. And then I have to come down to -4. But that's not in and of itself so hard. So that's about 5, and -4 is right on that line. So that's the point 5 minus 4. So that's 5 minus 4. And then I go -3 and 3. So again, -3 is going to be right there in between -2 and -4. And 3 up positive is going to be about right there. So that's about -3 and 3. And our slope is going to look this way. So here's the thing I'm going to tell you. If you're walking, not the best in the world, but good enough for these purposes. So I'm going to make a claim. I'm going to claim right now that when I find my slope, that it will be negative. And then I'm going to talk to you about how you can check just by looking at it whether it's going to be negative or positive. So again, I have 2 points. 5 minus 4, it does not matter where you put these. And -3 and 3. So my slope is going to be -4 minus 3. And then 5 minus, so here, let me do something. I want to write the minus in a different color. Minus in a different color. That minus is inherent in the formula. So that means the -3 here can't use it. It has to bring its minus with it. So -4 minus 3 is -7. 5 minus a -3 is 5 plus 3. So that's equal to -7/8. And indeed, it is negative. So the point here is that I knew it was going to be negative even before I did it. So how are we going to find that out? So let's get another canvas here. So if you have does that even work? Let's just draw one. Not that color though. So again, drawing. I could go to GeoGebra right now. So just imagine that you're an ant and you're walking from left to right. If you're walking and you're going downhill, then that's negative slope. Even just slightly downhill. If, on the other hand, you're walking from, again, left to right, and you're going uphill, that's positive slope. If there is no hill, meaning no slant, that's zero slope. Makes sense, right? You're walking on the level. And if you're falling in free fall, what is that? That is a vertical line. You can't walk on it at all. Then that is slope undefined. Okay, so there's that. Let's go back to what we're supposed to be doing. So this is really, objective 2 is really nice. The only thing that they do is they throw at you this f of x stuff. But remember, when we say that something is f of x, you're going to be seeing it again. Just a reminder, we always have f of x denotes a function, and f of x is equal to y. So a point x, y on the function is a point x, f of x. So those two are the same. So that's what we normally do when we see f of x. And here's the easiest way to do that. So this is example 3. So we just want to find the slope. So we have f of x is equal to 2/3 x plus 4. But all I have to do is remember this right here, that f of x is really equal to y. So that's y is equal to 2/3 x plus 4. And then if we remember, y is equal to mx plus b, where m is the slope, then it's very evident that m in this case is equal to 2/3. And we found it. That's it, done. We don't have to do anything else. So let's do another one. So an equation in slope-intercept form is just the equation I gave you. Y is equal to mx plus b. Remember, that's the slope. The point 0b is the y-intercept. So the question is, the equation y is equal to 7 in slope-intercept form. If so, what is its slope and what is its y-intercept? Let's think about that. That's a good challenge question for you. Y is equal to 7. Well, if we go over here, I actually say horizontal lines have zero slope. Their equation can always be converted to an equivalent form, an equivalent equation of the form y is equal to b. So if you just have that somewhere written down, you know this is a horizontal line, and the slope is equal to 0. So let's do that. Y is equal to mx plus b. So y is equal to, our slope is 0. So y is equal to b. So what's my b value? This tells you y is equal to 7. So the original equation in slope-intercept form would be y is equal to 0x plus 7. So let's do 4 and 5. So number 4, pretty much the same ordeal. we have f of x is equal to minus 4x plus 6. And we change f of x to y. Y is equal to minus 4x plus 6. And we remember that y is equal to mx plus b is the slope-intercept form, where m is the coefficient to the x term is equal to minus 4. So the slope is equal to minus 4. Let's do another one. Here we have find the slope of the equation. So here the easiest way to do it when you're asked the slope is just to solve for x. So let's find the slope of the equation. Sorry, solve for y is what we're going to be doing. So we're going to find the slope of the equation. 3x minus 4y is equal to 4. The easiest way to do it is to solve for y. There are other ways to do it. So let's solve for y. We've done this before. I move the x term over to the other side. It changes sign. I scoot the constant term over and put its sign in front of it. Then I'm going to divide both sides through by minus 4. So I find the following equation is correct. Y is equal to 3/4 x. Remember, a negative divided by negative is a positive. And 4 divided by minus 4 is minus 1. So that's in our intercept form. Y is equal to mx plus b. They're not asking for where the y-intercept is, so our slope here is equal to our value of m, which is equal to 3/4. So let's do the next one. Let's actually use these in an application. It's funny that they're doing this because it has to do with Disney, Disney World, and that's here, not in California. So the adult one-day pass price for dollars Y, so Y stands for dollars, of an adult one-day pass is given by Y is equal to 4.07x plus 66.4, where Y is the number of years since 2006. Use this equation to predict the ticket price for 2021. So let's do that first. So we're given an equation. And here there's a different, let me first start about this. What makes the Cartesian plane nice is that we can graph or plot all kinds of things. So here's my y, and here is my x. The y in this case stands for ticket prices. What type of a ticket price? The price for the adult one-day pass. I've only been to Disney World once, and I'm in the process of buying a one-day pass for Universal because I've got cousins coming down in October. So I know the current price for a Universal Florida resident one-day price as of today. But this is the ticket price. What is our x? X is the number of years since 2006. So where would 2007 be on my, it would represent 1. Where would 2012 be? It would represent 6. So y is the ticket price, and it's given by the equation y is equal to 4 0.07 times x plus 66.4. So here, people, this is a real-life model. So for a model like this, if it were on the exam, I would be okay that you use a calculator to do the decimal multiplication. Because it's a real-life model, and real-life models, that's exactly what calculators are for, is to compute those. But anyway, we're going to use this equation to predict the ticket prices for 2001. So there's an underlying assumption. By saying that this is the ticket price, the assumption is price increase, or as far as that goes, decrease, is linear. Now, I don't know if I've told you, I have two masters. One is in mathematics and the other is in philosophy. And this is an interesting philosophical question. We can actually observe our past price changes, and we can see that they're linear. But this is assuming that in the future, they remain linear. And how we know that is called the problem of induction. How do we know the future will resemble the past? In this case, we're just going to assume it does. We're just going to assume it does. If we turn out to be wrong, our model will show it. So we're going to assume that the equation here, which is clearly a linear equation, models the prices of tickets. So use this equation to predict the ticket prices for 2021. Well, y is the value I want to know, because y is the ticket price. So I have to find the value of x. But x is equal to, the start value of x is the same as 2006. So to find the value of x, we subtract 2006 from 2021, and we get 15. So we just now plug and chug. So we have y is equal to 4.07 times 15 plus 66.4. Well, that turns out to be equal to, I've already done the math with the calculator, $127.45 is the predicted price in, what was the year? What is the year? 2021, next year. I'm not for sure when this was published, and this is Disney, and I just did Universal Studios for a resident, and it was very much close to this value right here. I didn't actually buy it yet. I have to talk to my cousins to see, do they want express passes? All this stuff I don't know about. I mean, I don't actually do Disney or Universal, but I rather imagine I'll have fun, but I also imagine one of the reasons I'm being asked to go is they're a family of 5 and I'm the 6th, and their smallest loves me to death, so I'm going to be babysitting the 5-year-old, which is fine. So there you go. We answered question 1. Question 2. What does the slope of the equation mean? In this case, the slope means, if we were to look at the actual line drawn, so this is the data points. So hopefully some of you will take statistics, and this is called a best fit model, a best fit linear regression model. And we can actually draw the line that best fits the data. And if you take statistics, which I'll be teaching for the first time in the spring, I'm pretty sure we will deal with that. What is the slope of this line? It's positive, right? If we're an ant walking, we're going uphill. So the slope of the equation is positive, and it means ticket prices are increasing. And then the next question, what does the y-intercept of the equation mean? Well, the y-intercept is the value of y when x is equal to 0. And when is x equal to 0? When the year is 2006. So in the year 2006, the starting price, or the price of a one-day adult pass, is $66.40. So it's pretty cool. So math is used in economics all the time. This visualization of math in charts and graphs and 3D, it's just absolutely beautiful. It's one of the most important advances as far as being able to visualize mathematics, and it's been around since the time of René Descartes. So let's do another example. For the period of 2010 through for the period of 2010 through 2040, the number of people Y age 85 or older in the USA. So our y-axis, the values of our y-axis stand for people 85 years or older living in the USA, is given by the equation y is equal to 269,370x, that's a pretty steep slope, plus 48,697,000, where x is the number of years since 2010. So estimate the number of people age 85 or older living in the USA since 2015. So we know that, don't we? Let's actually kind of go through this and see what we've got. So the slope of this equation is the slope, that's the slope right there. Is it positive? Yes, it's positive. So that means the number of people, the age 85 or older, is increasing over time. What does the y-intercept mean? 48,697,000. It's the number of people age 85 or older living in the United States at the start year of 2010. So let's go ahead and do this. So our start date, we have the equation, y is equal to 2. This would be another one I would be okay that you use a calculator with, because it models real life. Real life is not so kind as to make all of the math be nice and amenable to multiplication by hand. That's one of the reasons we have computers and calculators. So the slope, m, is 269,370. So we need to find the x value. So the x is going to be 2040 minus 2010. That's easy. So that's 30. So we just plug in 30. This is actually something you should be able to do, but I don't see any point in it, to be honest with you. Just pull out a calculator. And that's going to turn out to be, I'm just looking at my own answers over there. The estimate, what we got from here, is 50,042,000 people. What kind of people? People 85 or older. And the exact number, that's the estimate from the formula, and the exact number turns out to be, I don't know how I give it. I think I must have looked it up. I don't know why, but somehow I've got the exact in my notes, so I'm going to give it to you. The exact is 50,043,800 was the exact. So you see it's a really, really good estimate. We're off by 1,800 people. And that's a time span of 30 years. So this is some of the ways scientists to model things as diverse from climate to population changes to the growth of COVID-19, which is exponential. It's not linear, it's exponential. You'll see that in college algebra. Can predict and model the future. It's of course under the assumption that the past is going to resemble the future, and when we get way, way, way out in time, thousands of years, that assumption gets weaker and weaker and weaker. But as long as it's just a short period of time, we're usually pretty dead on. So let's go on to the next, objective 4. Finding the slopes of horizontal and vertical lines. We already know what they are, right? The slope of a horizontal line is 0, and the slope of a vertical line is undefined. So all we have to do is recognize the equations for horizontal and vertical lines. So let's go back to what I have written down. Vertical lines have undefined slope. The equation can always be converted to an equivalent equation of the form x is equal to c. Horizontal lines have 0 slope, and their equation can always be converted to an equivalent equation of the form y is equal to b for some real number b and c. So back to where we were. So find the slope of the line x is equal to minus 5. Well, that's the equation of a vertical line. So the slope is undefined. Find the slope of the line y is equal to 2. That's a horizontal line. The slope is 0. Nothing else to be done. And the slope of a vertical line is undefined. The slope of a horizontal line is 0. So here we have a little graph with stuff I've already showed you. If you're an ant and you're walking uphill from left to right and you're going up, it's positive slope. If you're an ant and you're walking from left to right and you're going downhill, it's negative slope. If you're on the level, the slope is 0. If you're in free fall, undefined slope. What about parallel lines? Well, if we notice these are two distinct parallel lines, they have the exact same slope, but they have different y-intercepts. So that's the reason I say over here, two distinct lines are parallel. Actually, this is stronger if and only if they have the same slope and different y-intercepts. So an if and only if, I'm not going to talk to you about that right now. If you get into college algebra next semester and you have me, I will talk about if and only if. It's much stronger than an if. It's an if and only if. Back to our thing. Now let's look at perpendicular lines. Notice this little box they've drawn right here. So if I draw two perpendicular lines, let's actually go to GeoGebra. So I'm going to draw another line perpendicular to this one. Now here's a whole bunch of lines, but I want it to be at a right angle, their intersection to be at a right angle. And I'm eyeballing it. I don't have a protractor, maybe about right there. But if I knew the slope of this line, and I know the slope of this line, I can find out if those are really indeed perpendicular by multiplying them together. And if the product of their slopes turns out to be -1, then it's perpendicular. And let me go back to here. There is a little, two distinct lines are perpendicular if the product of their slopes is -1 and they are neither horizontal or vertical. So I've got to tell you what happens if they're horizontal or vertical. If two lines, if a line, just do it this way, horizontal, let me even do it this way, any horizontal line is perpendicular to any vertical line. So there we have all lines taken care of in that bit of information right there. So let's go back and see what exercises we're supposed to do. So let's find out, are the following two pairs of lines parallel, perpendicular, or either? So we need, the question always depends on their slope. So the first thing we do is we find their slope. We have to find their slope. So first thing, find slope. So I have, this is 10a. So I have two lines, 3x plus 7y is equal to 4. And over here, so these are two lines, mind you. 6x plus 14y is equal to 7. So let's solve each one of these for y. So 7y, taking the 3x and putting it on the other side, it becomes negative. Then I'm going to divide every term through by 7. So y is equal to minus 3 7x plus 4 sevenths. So the slope is minus 3 sevenths, and our y-intercept, let's write down that information too, is equal to 0, 4 sevenths. Let's do the same thing over here. I'm going to solve for y. I'm going to move the 6x to the other side. It becomes minus 6x. I'm going to scoot 7 over. Then I'm going to divide both sides by 14. So that gives me y is equal to minus 6x divided by 14. I'm going to simplify that to minus 3 sevenths because I can cancel out a 2 in each of those factors. Minus 6 divided by 2 is minus 3. 14 divided by 2 is 7, so I divided top and bottom by 2. The equality is the same. And 7/14 is another way for 1/2. So my slope over here is minus 3 sevenths, and my y-intercept is 0 and 1/2. So the slopes are the same, and the y-intercepts are different. So these are two, so conclusion. Same slope plus different y-intercept. It could be x-intercept, but we did y-intercept. Means parallel. So I'm just going to give you again, if this is one line, the slopes, I know that can't be, the slopes are negative. So if this is one slope, so they're going to be something like that. They're different lines, but they're going the same direction. So let's do the next one. So here we're given, again, two lines. Minus x plus 3y is equal to 2. That's one line. And the other line is 2x plus 6y is equal to 5. So let's figure this out. So I'm solving for y. So 3y is equal to, I move the minus x to the other side and it becomes x. And I scoot the 2 over. Now I'm going to divide both sides by 3. So that gives me y is equal to x over 3 plus 2/3. Now here you just have to know, and you should know, that x divided by 3 is the same as 1/3 x. So my slope over here is 1/3, and my y-intercept is 0, 2/3. Come over here, let's solve. 6y, I'm moving the 2x to the other side, scooting the 5 over and keeping it signed. I'm going to divide by 6, divide by 6, divide by 6. So I have y is equal to minus 2/6. That's the same as minus 1/3. Minus 2 divided by 2 is minus 1. 6 divided by 2 is 3. So my slope, m, over here is, I'm going to call this m1. I'm going to call this m2, is minus 1/3. And our intercept is 0, 5, 6. And I just realized something. I left out an important part of this. If the product of is minus 1, let me make sure that's right. I'm thinking I left out something there. No, the two non-vertical lines are perpendicular if the product of the okay, that's fine. I had it right. Sometimes I will actually give the definition of that quite different. I will talk if the slope, anyway, I won't give it to you. So look, their slopes are not the same. So the slopes are not equal. So they cannot be parallel. So the question is, as soon as we discovered that the slopes are not equal, because 1/3 is not equal to minus 1/3. So as soon as we find that their slopes aren't equal, we don't care anything about the y-intercept. Makes no difference. So the question is, are they parallel? Well, the product needs to be minus 1. But the product of these is minus 1/9. So they're not perpendicular, they're not parallel, they're not this thing over here. So the question is, are they perpendicular? So they're not perpendicular. Because minus 1/9 is not minus 1. So let's actually see what those equations are. Let's actually plot that. Let's go to GeoGebra just so we can verify. So we're given, let me sketch them down, minus x plus 3y is equal to 2, and 2x plus 6y is equal to 5. So going to GeoGebra, I'm going to refresh the page just to get rid of everything. And over here you can literally type in what you want. I'm going to do minus x is equal, plus 3y is equal to 2. And there's that line. Do another line. We have 2x plus, not equal, but plus 6y is equal to 5. And you can clearly see that these two lines are in no way perpendicular. I was hoping that I actually had an example of two that were perpendicular, and I don't. So I can create one for you. Shall I create one for you? Let me just do a really easy one, okay? So I always like to give a positive example. So suppose our line is 3x plus 5 and y is equal to minus 1/3 x plus 20. So our slope 1 is equal to, because they're already in slope-intercept form, and our slope 2 is equal to minus 1/3. So let's multiply slope 1 times slope 2. If the answer turns out to be minus 1, then they're perpendicular. So that's 3 times minus 1/3, which is the same as 3 divided by 3, which is 1 times minus 1, which is equal to minus 1. So let's actually go to GeoGebra and see and verify that. 3x plus 5, I won't remember it, dude. People, my memory is, I wanted to get the exact thing, and I don't want to go back. Let's reload. So we're going to do minus x, I just want you to see, plus 3y is equal to 2. Okay? Next line. Did you all see what I did there? Typed in the wrong thing. Be patient with me, okay? So y is equal to 3x plus 5. Here's line 1. And y is equal to minus 1 divided by 3, 3x plus 20. That's fine. Since it's plus 20, it's way up there. And you can see right there, it's perpendicular. And we can actually play around with this. I'm going to change the denominator to 4. You can barely notice the difference. Did you notice a difference? Here's 3, and here's 4. Hardly notice a difference. You can, but the point is, mathematically you can see much better than you can visually see. Instead of putting 3 there, what if I put 3.00021 or 25? Looks perpendicular to me. Well, it actually changed it to that, but it wouldn't be. If it was actually minus 1 divided by 3.0025, it would be really close to perpendicular, but not quite. So that's, I think, all we have for 3.4. Yes, it is. So again, I'll leave this up here for you for the last screen, just in case you want to jot it down or take a screenshot. Okay.